So this one is experiment number 9. First we'll do the analog link, then we'll go to the digital link. So in this experiment you need to follow some steps, because all this connection won't be done when you're giving your model practical. Now for that, what you'll have to do is, first of all, you'll make the connection. So switch off this thing and look at these. First of all, you'll select the 850 nanometer optical transmitter. So you have two optical transmitter over here. One is 850 nanometer, the second one is 650 nanometer. So we need to use the 850 nanometer. So see, the 850 nanometer is connected to the receiver. Bottom half of this setup is the transmitter, and the top part is the receiver. So this is the receiver and this is the transmitter. Two transmitter, one receiver. For this experiment, we are using 850 nanometer for the analog link. Now, after that, what you have to do is you have to check this switch. This switch should be in the analog position when you're doing the analog link, and in the digital position when you're doing the digital link. After that, we'll make the connections. So the first connection that we'll make is IO1 to IO2 to analog in. So IO1 is connected to IO2, which is then connected to analog link. So this 3-terminal wire you'll have to use IO1 to IO2 and then IO2 to analog in. After that, what you'll do is connecting the transmitter part to the receiver part. So for that, IO3 in transmitter is connected to P31 in receiver. So IO3 in the transmitter is connected to P31 in the receiver. So once you have made all the connection, most of it is done. So over here, remember this IO1 is directly connected to IO2. That means IO1 and IO2 are right now shorted. So for that reason, over here, IO1 is directly connected to IO2. That means IO2 gives you nothing but the input. So IO2 is connected to the first channel of the oscilloscope, which is your input channel. Now IO3 is connected to the receiver. So IO3 is your output. So IO3 is connected to the channel number 2 of the oscilloscope, which is your output. So for the analog link, you'll have to use the scientific function generator, and for the digital, to generate the square wave, we'll use the top one. So now, for the analog link, what we'll do is we'll set the, we'll switch on everything first of all. Then we'll do, what we'll do is we'll set the, what do you call it, the function generator to get a sine wave from changing the function. I think all of you know that. And after that, we'll change the frequency, and we'll make sure we'll come to the oscilloscope, and we'll switch off channel 2, which is our output channel, and we'll keep the channel 1 on, which is our input channel, and we'll measure. So which is around 1.16 volts. So you want a 1 kilohertz 1 volt input signal. Now if it's not set initially, what you'll have to do is, this is to vary the frequency, as you all know, and this is to vary the decimal points. For example, if we are at 1000 hertz and we want to go to 1 kilohertz, instead of just rotating it, you can just go like this and you are at 10 kilohertz right now. So to change the decimal places, you use these two keys. And if you don't have 1 volt signal over there, what you do is you change the amplitude using this knob, so till you get 1 volts. Now after that, after you have set the signals, that's done for that part, and you have your input signal over there. Now these cables can be sensitive sometimes, so take care of that. Now after that, what we'll do is, it's very simple right now. You just don't touch the amplitude knob. You just go from 10 hertz to 1.5 megahertz. What you'll see is the output voltage rises, becomes constant for some time, and then falls and becomes false. So just like a band pass filter. So you'll get a figure like this. So very simple, and this is what you calculate: G is equals to 20 log 10 V out by V in. So for that, you just simply vary the frequency from 10 hertz, starting from 10 hertz. So for example, I am at 1 hertz. So instead of just rotating it, I'll just go 1 decimal down, 1 decimal down. So okay, so I think so 9 hertz, 10 hertz. So we'll start from 10 hertz, move till 1.5 megahertz. This oscilloscope can go to 3 megahertz. So sorry, this function generator can go to 3 megahertz, so not a problem. And you get your table, and that's it for the analog.